All right, hi students, Mr. Clucky here again. At this point, you should have already completed the video where we conducted the investigation and we took down our results. So in other words, we would have completed page 3 of our packet, which was section D. It would have looked like this. And we recorded our results and then we transferred those numbers into whole numbers using the multiplication by 100 strategy, or moving that decimal point 2 spots to the right. What we're going to do now is we're going to make a graph of our results. So oftentimes scientists will graph results to see any trends or patterns in our data that we wouldn't otherwise see by just looking at numbers. All right, so we are going to graph our data and make a key to show which data is for repulsive and which data is for attractive forces. So at this point in time, if you are an in-person learner, I want you to go ahead and find your packet and find section E, and then directly behind it, our graph. Whereas if you're a remote learner, I want you working on your digital document, and then I will understand that you cannot make a graph digitally. However, you will be able to describe what the graph looks like. So I'm going to go ahead and tip the camera down so you can see my graphing paper here, and I'm going to turn it backwards so that it is straight up and down for you guys. So looking at our numbers, the first thing that we're going to want to do is we are going to want to create some labels for our graph. So we will see we've got a y-axis here running up and down and an x-axis going across. Our y-axis goes beyond the x-axis down here because we are using negative numbers, okay? So we will be graphing both negative numbers and positive ones that are up here. So let's start first with our y-axis. So our y-axis is going to have a label. Going up and down, our label is going to be the force in ounces. So on this side, we're going to want to put moving up and down, and we're going to want to put down, this is our force in ounces. So I'm going to start right here. And I'm going to say that this is force. Make sure that I'm writing the correct direction for you guys. Force. I'm going to flip it around here. Force in ounces. And I'm going to also abbreviate that, which is OZ. And I'm also going to put a times 10 to the second, because that will indicate for us that our numbers have been switched. They're actually a decimal point, but we've been altering them so that they are times 10 or times 10 to the second power. Right. Once you have copied that in here, what we're going to go ahead and do is we're going to go ahead and fill in our numbers. So working from our x-axis, we want to locate this as our 0 mark, and we're going to count up by a certain range to fit all of our numbers. Well, to figure out what that range is, we have to look and see, well, what range of numbers do we have? We have a range of numbers anywhere from 3 all the way up to almost 90 for our repulsive forces, and 3 all the way up to 133 or negative 133 for our attractive ones. Looking at here, and maybe counting in spaces, what would be a good scale to use? So after you've thought a little bit, you might recognize that we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We've got 12 lines. So counting by tens would be a good number that would fit all of our data. So we're going to go ahead and start labeling now our axis by tens. So count by tens up from 0 so that we get all the way up to 100 right here. And then we have 110 and then 100. And I can't write a 2 backwards. So we're going to want to put 120. So count up by tens. Now, at this point, we've done our positive axis, but we want to do the negative y-axis as well. So for this part, you'll want to get a different colored pencil, because we're going to want to have a difference between our repulsive and our attractive forces. So using a different color than before, you're going to want to mark these as negative numbers going down. So at this point, using our same scale, count by negative tens all the way down. And I will do that along with you guys. So negative 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And our scale down here stops at negative 110. Okay, you'll notice that our data doesn't fit that number, but we don't have any more graph paper. I'd rather not change our scale. So when we get to our lowest number, we'll just put it at the very bottom of our scale. But we'll get there when we can. All right, so we've got our y-axis label. We now need to label our x-axis. So for y was the force in ounces, what is our x-axis going to be labeled? All right, and you guys are correct. Our x-axis should be labeled our distance apart. So I'm going to label it down here and say distance apart. And that label is going to be in centimeters. And then we're going to want to count across on our x-axis by ones, because that's the unit that we've been using in centimeters. So we've got 0 located here. Then we're going to have 1, 2, 3, 4, and so on and so forth. Okay, so 1, 2, 3, 4, 5, 6. And we can stop at 6 because our data set of numbers doesn't go beyond 6 centimeters. We've got our y-axis labeled now. We've got our x-axis. Now we can go ahead and begin graphing our data. So at this point, I'm going to encourage you to pause the video here, or the video is actually going to stop, and I want you to graph the data. I want you to try graphing it on your own first. If you have difficulty, you can continue on and you can graph the data with me, but I'd like us to try graphing this first off if you're an in-person learner. If you're at home, go ahead and just continue. If you're a remote learner, and you're going to watch me graph this data for you to see. So our first data point is at 88, I believe, for a repulsive force. So we'll start there. So we're going to go 88 for a repulsive force. So 1 centimeter, 90, 88 would be about at that point in time. 73 at 2 centimeters. So find 2, 70, find where 3 might be at between 70 and 80. Then we've got 25. So 3, there's 30. 25 would be right splitting them in between. At 4 centimeters, we had a force of 12. So there's 10. 12 might be around right there. At 5, a little bit above the 6 point. And then at 6 centimeters, we were at 3, so a little bit below that. Okay, so we've got 1, 2, 3, 4, 5, 6 dots there. We're going to switch our colors and go back to our red pen. And we're going to go to the other color, and we're going to graph our attractive forces now. So our first one is at negative 133. Now, because that goes off our scale, I'll just go to 1 centimeter and go to our very bottom number, and that will be good enough for us. And then I'm going to do negative 70 at 2 centimeters. So 70, there's 2. Then I've got 27, so negative 27 at 3 centimeters. So 30 is right there. 27 might be about right there. Then I've got negative 13 at 4, so there's 10, negative 13. Then I've got negative 6 and negative 3. All right, so again, I've got 1, 2, 3, 4, 5, 6 dots there. We now are going to want to connect these lines to make a line graph. So go through and connect all of your lines. And you'll notice a cool little pattern that begins to emerge as we connect our lines. And then I'm going to go through and connect my repulsive force lines. All right, so now both of my data sets are graphed. And before we finish up and look at this, we have to give our data our title. So when we think of a title, we have to go back to what are we even investigating here? So thinking back to our hypothesis, what explanation are we investigating? Well, our explanation or our investigation was, does distance affect force? So we want to title this, the effect of distance on magnetic force. All right, so now we have our title. So looking at our data, let's see if we have any trends that pop up right now. So looking here, starting out with repulsive forces, what trend are you noticing happening to our force as we increase distance? Well, the trend that I'm seeing is that as distance increases, as we go across, our force is decreasing. So we have a negative linear relationship, meaning that as our x-axis increases, our y-axis or our trend is going to decrease. So if I have a very large distance between my repulsive magnets, force is going to significantly decrease. Whereas if that distance increases, my force will get very, very strong. And it looks rather almost, maybe not linear, but almost exponential, where we see we've kind of got this curve where the highest forces are really close to that magnet. Now, opposite of that, let's look at the attractive forces. Well, at really, really, really close distances, notice again, there's hardly any force at all, right? Remember, these these negative numbers, right? Very small negative numbers are really far down here, right? Because with negative numbers, the biggest negative numbers are closest to zero. Okay, these are very, very, very small negative numbers. Okay, as we get closer together, all right, or as we get further apart, notice how our negative force increases exponentially as well. So again, negative numbers, the biggest negative numbers are the ones that are closest to zero. Okay, so as we get closer, notice how those numbers, right, that strength really increases as we get very, 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 very far away. Okay, so as distance increases for a repulse or for an attractive force, all right, our force is increasing a lot. All right, so I want us to think about our predictions. How does what we graphed compare to our predictions? How does what we graphed compare to what we predicted? Well, go back in your packet and look. What do we predict was going to happen? And what we'll see is we should have predicted this exact same trend. All right. So at this point, your graphs have now been made. Go ahead and move on to the next page where you can look at your interpretation and discussion of your results. There are 2 questions you need to answer. Make sure we answer those. Thank you, students.